This video is based on MySQL documentation on window function. Source links in the description section. Part 1. What are window functions? Consider the following table called employees, which stores records of 100 employees, including details such as name, department, salary, and hire date. To calculate the average salary, we can use the following aggregate query. As you can see, this query returns a single value, the total average salary, but collapses the table to just one row. To get a more detailed view, we can use the group by clause to group salaries by department. While this gives a more structured answer, the rows are still collapsed into smaller groups rather than maintaining individual employee records. Now let's introduce the over clause and see what happens when we apply it to an aggregate function. Unlike the previous aggregate function, this query retains the original number of rows while still computing the average salary. By adding the over clause, we effectively transform the aggregate function into a window function. Summary: a window function is similar to an aggregate function. It operates on a set of rows. However, unlike aggregate functions, window functions do not collapse rows. To convert an aggregate function into a window function, simply add the over clause, which is a required syntax component. Part 2. Window function syntax and the over clause. Window functions have a flexible syntax, but the fundamental structure can be represented as follows. The first part of the syntax, window function, can be either an aggregate function such as min, max, and count, or a specialized window function such as row number and rank. Some window functions accept arguments such as average and lead, while others like rank and row number do not require them. The second part of the syntax is over clause. This is a required component that distinguishes window functions from aggregate functions. It allows us to define how rows should be grouped and ordered. Let's write a new query. Imagine our manager wants to determine the total salary that the company is paying its employees. We can use the sum function as a window function. This query calculates the total salary across the company, but maintains the original rows. Now let's say we want to determine who is the highest paid employee. For this, we can use the rank function. However, this query results in all rows having the same rank 1. Understanding over with partition by and order by. The over clause specifies which rows should be considered for the window function and in what order. If we don't define partition by or order by, the function considers all rows equally. Since we didn't specify an order, every row is considered first, leading to all rows having rank 1. Similarly, the sum function without an order by returns the same total sum in every row because it considers all rows at once. In the next section, we'll see how to fix this. Part 3. More on order by and partition by. Now, let's see how our results change when we include order by in our over clause. Let's fix the previous query to find the highest salary in our company. By adding order by salary descending, we instruct SQL to rank employees from the highest salary to the lowest. The highest paid employee will have rank equals 1. The second highest will have rank equals 2, and so on. However, if multiple employees have the same salary, they receive the same rank, and the next rank is skipped, which is the behavior of rank. To avoid gaps in ranking, we can use dense rank instead. Next, let's modify our previous sum window function and add order by clause. This query calculates a running total from the highest salary to the current row. While this may not always be useful, it effectively implements a prefix sum in SQL, which can be valuable in specific scenarios. So far, we've applied ranking to the entire table. But what if we want to rank employees within each department instead of the whole company? Partition by department ensures that ranking happens within each department separately rather than across the whole table. Order by salary descending ensures the ranking is from highest to lowest within each department. Similarly, we can compute the average salary per department. So far, we've used partition by to group rows by specific categories, but sometimes we need even finer control over how our window functions operate. In the next section, we'll explore window frames, which allow even more flexibility in defining row groups within partitions. Part 4. Window functions fine-tuning with window frames. In our previous examples, we used partition by and order by to define our window, which effectively encompassed either the entire partition or an ordered subset. However, we can achieve much finer control over the window size using window frames. Window frames allow us to specify the exact set of rows included in the calculation for each row. There are two primary types: row-based and range-based. Let's illustrate row-based frames with an example, calculating the running average salary within a window of 3 rows. In this query, defines our window frame. For each row, the average salary is calculated using the current row, the row immediately preceding it, and the row immediately following it. The general syntax for row-based window frames is: the upper bound and lower bound can be any of the following: unbounded preceding, meaning it extends the window to the first row of the partition; unbounded following, extends the window to the last row of the partition; n preceding, includes the n rows before the current row; n following, includes the n rows after the current row; current row refers to the current row. Here are a few more examples. This includes all rows in the partition. It's equivalent to an empty over clause when no partition by is used. This calculates a cumulative aggregate from the start of the partition up to the current row. Importantly, if you only have an order by clause in the over clause, this is the default window frame. This will average the current row and the 2 rows before it. Range-based window frames operate on the values within the order by clause, not the physical row positions. This is a crucial distinction. Consider the following. This includes the 10 rows preceding the current row, based on their physical position. This includes all rows where the value of order by column is within 10 units less than the current row's value. Here's an example. This query counts the number of employees whose salary is within 10,000 units less than or equal to the current employee's salary. Part 5: Expanding your window function arsenal. We've already explored sum, average, count, rank, and densrank, and we've seen how rank and densrank handle ties. But the world of window functions extends beyond these basics. Let's check into some essential window functions. Row number is a function for assigning a unique sequential integer to each row within a partition. Think of it like adding a numbered column in a spreadsheet. This query assigns a unique number to each employee, ordered by hire date in descending order. Even if 2 employees have the same hire date, they'll receive distinct row numbers. Lag allows you to retrieve the value of a row, a specified number of positions, before the current row. This is incredibly useful for comparing current values to previous ones. Here, we're comparing each employee's salary to the salary of the employee hired immediately before them. The lag in this part means, get the salary from the row 1 position before, and if there's no previous row. Lead is the counterpart to lag. It retrieves the value of a row with a specified number of positions after the current row. This query fetches the salary of the employee hired immediately after each employee. First value returns the first value within a partition or window frame. In this example, we're getting the salary of the first employee hired in each department. Last value returns the last value within a partition or window frame. This query retrieves the salary of the last employee hired in each department. It is very important to add the range clause here, otherwise the last value will be the current value due to the default range window frame.